I'm going to post this on Blackboard, and somewhere I did it myself just so I could understand the numbers, but I couldn't find where I went through the process. But it's really hard to find the formulas for doing ANCOVA, but this is an example of how to do the calculations, or how ANCOVA does stuff to make the adjustments to the group means. And so I'm going to post this on Blackboard. Anyone who wants can work through it, or just look at it and say, no, that's too many numbers to deal with. Okay, so the roles, I think I've already talked about most of this, but we're dealing with pre-treatment differences between the groups. Things people come in with already and we don't have any control over. And if we have a good covariate, it's going to adjust the values within the groups. And so it's based on averages of the covariates. So if you ever decide to look at this thing, it kind of shows you how the math works. And I say it adjusts the group mean, but it's really making adjustments to the individuals that results in changes to the group means. And it will, I'm trying to remember what I meant by that, but it's not key to the discussion here. The big thing is remembering that what ANCOVA is doing is making adjustments based on things outside our control that might influence the results. So you have if you have a good covariate, you can find true differences more than if you don't have that covariate in the model. On the other hand, sometimes the covariate makes your differences go away. So it really is trying to make an unbiased adjustment. So you may say you're going to do an ANCOVA, when you put that covariate in there, or you do an ANOVA, then you do the ANCOVA, and you realize, oh, my differences went away instead of my differences got highlighted. It's all because of the adjustments. It's also reducing the probability of that type 2 error, and so increasing the power. So the way we do this is really pretty simple. We do our standard general linear model. And by now you're used to going in there, plugging in the dependent variable, the fixed factors. Now we put something in the covariance box. We have a variable that's a covariate, we stick it in there. And then we run our ANCOVA. So here's an example of a one-factor ANOVA. This isn't an ANCOVA. And all I did here was I have an A independent variable and Y is my dependent variable. And so this one, the results are not significant. The power is fairly low. And then when I plug in X, my covariate, and keep A as the independent, Y as the dependent, my significance really pops out and power goes up substantially. So X being in the model is helping to control for something extraneous. Now, we don't know yet if X is an appropriate covariate because I mentioned there are assumptions that apply to ANCOVA that don't apply to other tests. And so we'd have to check X to see if it really fits in there. And this is one of those things that you might say up front you're going to do an ANCOVA, but you'll have to really wait until you have the data. And once you have the data, you can test the assumptions. If the assumptions hold up, then you can use ANCOVA. If they don't, then you have to go back to ANOVA. Even if that means that you're not getting the significant results that an ANCOVA showed.
Do you have to, when you're going through IR, do you have to state what test you're going to be using in the beginning? Or?
Through IRB?
IRB, sorry.
Yep. No, for IRB, they're really mainly concerned about safety of the participants.
Okay.
So they don't care about that, but what they're going to want to do is see what instructions you're giving to the participants, what the survey looks like. If you're going to be doing any follow-ups, they want to see examples of those. So there's a lot of stuff you have to have in that IRB packet that it means you really have to have planned your contacts with your participants very carefully. And that has to be in your proposal too. Yeah. So, but they don't care about what kind of statistical tests you're doing. They do want to know things about why the study is important.
Right.
Which especially comes into play if you're dealing with a study where there is some risk to the participants. For example, when John wants to insert probes in people's brains to measure how they react, IRB is probably going to look at, well, is it really worth doing that? And so...
Might not argue if they know who he's doing it to.
Yeah, that's true. He may be doing it to faculty at another university. Yeah.
So you gave me a C.
Yeah. And I think Dr. Brown in the course next semester plans to talk about the IRB process, because he was, I believe, on the IRB at West Florida, and he's trying to be on the IRB here, but right now I guess they have a large camera.
After us, right?
Well, actually, it's very helpful if you know someone who's on the IRB, because you know you can go to them, they can tell you, well, here's how I would react to this application. And he'll be honest with you and he'll say, well, I would not be in favor of accepting this application because of this part here. So it'll be good if he can get on it. Okay, so this is a one-way, one-factor ANCOVA. You can do ANCOVA with 2 factors, the same as with 1 factor. Here's one of the things ANCOVA does. It creates a custom model. Oh, sorry, I'm on the ANOVA.
Yeah, I was going to say that.
Yeah. This is full factorial. Now, with an ANCOVA, we have a custom model. We have the X, the A and C is the main effects, and then the interaction of A and C. We don't have an interaction based on the covariate. So that's one of the special things that happens with ANCOVA. So we would get results based on this model plus having the covariate in there. Okay, the assumptions. And I'm going to confess, I hate these assumptions. They're kind of strange at first. It's taken me a long time to start to realize exactly what they're doing. So I'm going to try to explain it the way I've come to see them. But we have, first of all, the same assumptions as ANOVA plus 2 special ones. The first one is independence of the covariate and the treatment. And remember I said that the covariate and the independent variable cannot be related in any way. So this assumption tests that. Then we have homogeneity of the regression slopes. And that's looking at the variance of the different groups within the data. So I'll give you some examples, or I'll show you how this works. So first, we would have to test independence of covariate and treatment. Actually, you don't have to do them in this order. This is just the way I'm doing them. For we would run a 1-factor ANOVA. And what we would do is put the independent variable as whatever our treatments are. So in our case, the independent variable would be that variable that contains information about the training group. Our dependent variable would be the covariate. And then we have these hypotheses here. First one is there's no difference. The alternate is there's a difference. Pretty much the standard set of hypotheses. Null, no difference. Alternate, there is a difference. And then we have our tests of significance. If we have significant results, in other words, if that p-value is below our alpha, then we cannot use the covariate. So we do this test, we decide if we're going to be potentially able to use that covariate. So this test would be run, and then we run the second test. So here's a little example of running the test where our dependent variable is x, whatever our covariate is. Our independent variable is whatever our treatment is. And we get this result, the sigma, or the significance, the p-value is 0.822. So 0.822 is a lot larger than 0.05.
Yeah.
So reject the null, fail to reject.
Yeah. Fail to reject.
Yep, we failed to reject the null, and based on our rule on the previous slide, what does that mean? Can we use the covariate?
Yes.
Yep, we can use the covariate because we reject the null, or we fail to reject the null, the covariate is appropriate at this point. The next test has to be run if we make it through that first test. And here, what we do is we create a custom model. And I'll show you how to do that in SPSS. It's actually pretty easy to do. And we look at the main effects of the fixed factors and the covariates, and we put the interaction of the fixed factors and the covariate. And remember I said that we don't have that interaction in our final analysis. This is in there just to test the covariate. So once we run this test, if the covariate passes, we take this interaction out. And that's something important to keep in mind if you do an ANCOVA, because I have seen people forget to take that interaction out.
Oh, okay.
And they get results and they're all excited and then have to say, well, you need to take that interaction out and then see what happens. And sometimes the results do change. So our null here is there's no interaction between the factor, the independent variable, and the covariate. The alternate is there is an interaction. And once again, if we find significance, covariate's not appropriate. And at this point, if we ran the previous test, and then we run this test, and we say the covariate's not appropriate, it goes away. So it has to pass both tests. So here's an example.
Yeah, go ahead.
So we have A and X, and then we put the interaction in just to test the covariate. We get a significance of 0.064. So if alpha is 0.05, then our test is not significant, the covariate's okay. Now, if we have two-factor ANOVA, we would put each of the main effects and the covariate, and then the interaction. Notice we don't have the interaction between the two main effects, or the independent variables. So this is a custom model again. And like I said, they're easy to do in SPSS. And so we do the test, 0.322, 0.05.
No.
Yeah, not significant, which means what about our covariate?
That you can use it.
Yep, we can keep the covariate. So we get rid of this, we adjust our models, and there's an easy way to get back to the original model.
When you